Hello guys, welcome to the channel. I hope you all are fine and doing great. Today we are going to discuss this GFG problem of the day, robots. So let's move on to the problem. So in this problem we are given two kind of boards A and B and a 1D array. Okay, in a 1D array like this, or you can say it is a string basically. In a string there are some character which is hash. Hash means a empty cell or a free cell in which you can do some movement. Okay, and two boards B and A. Now what this B can do? Now A can move to its left. Okay, like A can move from here, A can move to here. Okay, A can move to its left, like this is A, then A can move to this side. Okay, and while B can move to its right. Okay, like it is B, then B can move in this direction only. So and there are empty spaces as I already told you, but there is a condition that the boats cannot cross over each other. Like suppose if it is A, if it is B, it is A, and this is a string. Suppose this is a string, this is first, this is second. They cannot, then this string cannot be made like this, because you know B can go to this direction, A can go to this direction, so they both swap, but they cannot, because here they need to cross over each other, which cannot be possible. You can see they cannot cross each other. Okay, so and we are given the initial state, means the initial string sum s1 and a final string or final state s2. Then we have to tell whether this transformation or whether this movement of boards can be possible or not. Means from s1, by doing these steps, can we quote a string that is equal to s2. So here as you can see our B will move to its next trace. Okay, then it will become empty and here B will occupy this space, so we can take this. So answer is equal to yes. But here in this case, see, this is initial, this is final state. Here as you can see our B and A are swap. Okay, it cannot be possible because our B and A cannot cross over, and for this configuration they need to cross over. That's why our answer is equal to no. So let's move on to the solution, how we will do it. So first of all what we are doing, just a minute, I just erase it because I need it. So first of all what we are doing, we are taken two variable int a and int b. Then what we are doing, we are store the count of a's in string s1, means in initial string, and count of a in s2, means in final string. And if a is not is equal to b, means the count of a in our initial string and the count of a in our final string is not equal, then those configuration cannot be possible, so we just return no. Similarly, we will count the occurrence of B in S1 and count of occurrence of B in S2. And if they are not equal, we just return no. Okay, so this is our first step. Then in second step, what we are doing here, we are we are running a loop. Like suppose this is a string. I am by example. Suppose this is a string. Just a minute. Okay, here this is the string. Okay, and the second string is this. This is second string. Okay, so what we are doing, this is something big. So okay, so what we are doing, this is our final initial string and this is our final string. Okay, so what we are doing for B, as we know, for B here in our initial string, uh, suppose this is our initial space, and suppose here is a B. Okay, here is a B and this is some more string here and here. Okay, our initial string this is. Okay, suppose, okay, in our initial, it can there are some string this side, some string this side. Okay, and our B can do movement, very big it is, just a minute. Okay, and our B can do movement in this side. Okay, so from it what we can find out in our final string, final string, just in our final string. Okay, our b can become from this particular index, from this index to any index till last. Suppose this is our last index, our b can be any of between any of these index, because our b is free to do this side movement. But what is the one condition it should fulfill? In between this index and in between the five index where b is find, there is no a, there is no I should write it with some other color like this. There is no a because we cannot cross over a. If we find any a, then we just return zero, sorry, no, we just return no. Okay, similarly for a, also, no, first I should write the complete thing. Okay, suppose this is our a in our initial string. Okay, then our a is free to do this type of movement. Then our final string, suppose this is our zero index, this is the same index, this is same index as it. So we can found a from this at this index to any index till last. Okay, till last, in any index till last. Okay, so but here is also one condition, b should not come in between. Okay, if suppose here is suppose this is a suppose for a minute this is a and this is b. Here we found in first index, in 0th index we found a, in first index we found b, then it cannot possible, because for it we need to cross over b, and according to the problem we cannot cross over it. So basically this is the my approach, this is my approach how I am doing this particular problem. So let's move on to the solution now. So what I am doing, so I just cut it. So I am, first of all I am searching for b, then I am, first of all I am searching for b, then I am searching for a. Okay, how can I move it? Okay, I can just okay, suppose this is the function. Okay, it is crossover now. Okay, so suppose this is our function, just I just change my, suppose this is our function in which our I is equal to 0, our I is here, our j will represent the index in my final string, and left this step for now. Okay, if my si is equal to b, we are only dealing with b. Okay, if our si is equal to b, like here at 1, then for each index while our string j is and our sj is a free cell. Okay, because we can do movement while it is free. Okay, I just do j plus plus, sorry, while our cell is free. Okay, j plus plus. Okay, then and here as we found some number which is not is equal to free cell, then I will check if this is not the end of my string, this should be not the end of my string, or sorry, sd means it is the end of my string, so not sd mean it will true, means it is the end of the string, or else while my character is equal to a. Okay, character is equal to a, this or condition is not necessary to right now. Okay, because I modify my code, so this is not, from this I will get a wrong answer. Okay, so here you can left this statement as of now. Okay, this is not any statement. So okay, if means it is the end of my string, or this particular character is equal to a, then what we do means we don't found any b and we just return 0. Okay, we don't found any b, or if we found it then we have some a character in between. Okay, and we are doing j plus plus. Now why is I am doing this? Suppose here I will increase my I because my S1 I is not is equal to B and my J is still here. But you can see my J searching should be start from here. Suppose here is a B. Suppose for a minute here is a B. Okay, suppose the string is like free character. It is suppose it is a free character. Here is a B, here is a. Okay, then here is a B and my J is at this. So I just increase my, but I just increase I just do this operation and increment my I. But here it cannot possible. Now why it is not possible? I just write it more clear, I think, and you should all understand it. Suppose this is A, this is free character. Suppose this is a free character. Okay, suppose this and this is our free character. This is our final string. Suppose our J pointed to first index. So as you can see, our when our I is equal to 1, it is equal to B. It is equal to B, and our first character it is also is equal to B. Then but it cannot be possible if we don't write it, because our searching for our B, our searching should be start from this index and goes up to last index. Okay, because we cannot found a B here because our B cannot do movement on this side. Okay, this cannot possible. So for this I am doing maximum of I comma j. Suppose for this B I found a B here, and here next character is also is equal to B, and my J is here currently and my I is here. Then for this I will put out maximum of J, whether my J is here, sorry, my I is there, then I will store the maximum index of this and this. So maximum is equal to J, so my searching will start from J. Okay, will J, and I found J, so my J is also increment, so my J is here, so I will increment my searching from here, not from here. This max J comma I is only for this because I can do more movement only this side. So my searching should start from ith index and goes up to last index. Similarly for uh, A also. Okay, for A also what I am doing, I am starting from end of the loop for both and run the loop till the last. Okay, and now for this I am putting it to the minimum. Why minimum? Because our suppose A is this and this is our final string. Okay, this is our some initial string. Okay. This is some more string here, this is some more string here. Now suppose this is our I string and our J is still at this index. Okay, suppose our J is still at this index. This is our this is index is equal to I. Okay, these both are same indexing index. So as you can know, our A can do movement in only this direction. So if we found a here in between this string, suppose there are many 50 or 100 characters, suppose it, and if we found any A, then this A will not be for our work. Why not for our work? Why not for our work? Because if we found A here, then our this A we are searching for this A, and this A cannot do this movement. So we should find try to find a in this direction, in at least this direction, or till 0. So I should start from this direction and goes up to this. And suppose if my J is equal to here, suppose if my J, I just change out color, if my J is at this direction, then I can start from J because J is minimum. So from J I can do to 0th index. Okay, that's why I write down the minimum of J comma I. If my Si is equal to 1, then I will run a loop. If my character is still, means it is not the ending of the, or it is before ending of, like it is J while Sj is a character. Okay, like while Sj is a character, here J will not go to -1 up to, okay, while up to J is equal to 0, S to J means still there is a character, then only this while loop will work. Okay, then and our S2J is a free cell, then I will decrement it, then I will check if it is the end of our string. I am writing the not statement here. So you can, if this is end of my string or this character is equal to B, then I just return 0 and decrement, else while I just decrement J minus minus. And if I complete these two for loop, means I found all the B's that will support my B. Okay, like here this no statement will not work, this no statement will not work, means we found for all b, we found for all a, then at last we just return yes. So I am just showing you the code by running it. This is something complex implementation. This program has simple approach but some complex uh, modification. Okay, so guys, you can see all the 1130 test cases pass out. Time taken 0.1 because it is on approach, so time taken is generally this one. So okay, so guys, I hope you all understand it. This is the code, you can check it. First of all, we are count the number, then I am checking for b, then we are checking for a. If all the conditions satisfy, then we just return yes. Okay, so there are four conditions basically. For each a we have to find a that will surely point out this, or you cannot try to do this, you cannot need to you also submit without doing this, but I just tried it to increase some, like, it is not compulsory because a in code you will also find. Okay, but you can write it as well. Okay, it's more clearly visible now. Okay, so I hope you all understand it, you all like it, and if you still have any doubt, then just comment out. I will try my best to explain you. So thank you for watching this, guys. You can subscribe my channel and like the video. Thank you for watching.